Hi everybody, it's Fatih Arslan, who is software engineering department student in Istanbul University, and you are hearing me from Istanbul, which is the most beautiful city in the world. Now, in this tutorial videos, we will learn modern system analysis and design lesson, and with 16 chapters, we'll complete all modern system analysis and design chapters, and we will learn lots of necessary informations. Let's start with chapter 1, which includes the systems in development environment. Okay. Learning objectives. First, define information systems analysis and design. Describe the different types of information systems. Describe the information systems development life cycle, which is the most important one, SDLC. Explain rapid application development, RAD. Prototyping, joint application development, JAD. And computer aided software engineering, means CASE. Describe agile methodologies and extreme programming. Explain object-oriented analysis and design and the rational unified process. They say instead of this RUP. Introduction. Information systems analysis and design. You see three parts. Complex organizational process used to develop and maintain computer-based information systems used by a team of business and system professionals. This you see a figure, an organizational approach to systems analysis and design is driven by methodologies, techniques and tools. You see here is methodologies and organizational approach to system analysis and design. Here is techniques and tools. Okay. A modern approach to systems analysis and design. Before explaining that, I want to inform you about the importance of this lesson, because in your feature you will really need these informations, because these information are really important for your job life, and because of that I want you to listen carefully and concentrate on these slideshows and my voice at least. Okay. A modern approach to systems analysis and design. 1950s, focus on efficient automation of existing processes. 1960s, advent of 3GL, faster and more reliable computers. 1970s, system development becomes more like an engineering discipline. 1980s, major breakthrough with 4GL case tools, object-oriented methods. 1990s, focus on system integration, GUI applications, client-server platforms, internet, and new century web application development, wireless PDAs, component-based applications. Application software. Computer software designed to support organizational functions or processes. System analyst. Organizational role most responsible for analysis and design of information systems. Okay. Types of information systems and system development. First, transaction processing systems, TPS. Automate handling of data about business activities. And process orientation. Now, management information systems, MIS. It converts raw data from transaction processing system into meaningful form. Data orientation. Decision support systems, DSS. Designed to help decision makers, provides interactive environment for decision making, involves data warehouses, executive information systems, database, model-based user dialogue. Now you see a summary of information system types. Here's IS type, writing here, IS characteristics. For example, transaction processing system. Its characteristics: high volume, data capture focus. Goal is efficiency of data movement and processing and interfacing different TPSs. And here is system development methods. The system development method is process orientation, concerned with capturing, validating, and storing data, and with moving data between each required step. Now let's see developing information systems. System development methodology is a standard process followed in an organization to conduct all the steps necessary to analyze, design, implement, and maintain information systems. Now, system development life cycle, which I mentioned before because it's really important, SDLC. Traditional methodology used to develop, maintain, and replace information systems. Phases in SDLC, look, they are really important. First phase, planning. Second is analysis. Third one is design. Fourth one, implementation. And final one, maintenance. Now you see here a system development life cycle. As I mentioned before, first one planning, and then analysis, design, implementation, maintenance. Okay. Now planning. Now I will explain each phase. Planning. An organization's total information system needs are identified, analyzed, prioritized, and arranged. Really important phase. And second one, analysis. System requirements are studied and structured in this step. Okay. And third one, physical design. Last time I said you design, but you see it's a physical and logical design. In this part I'll tell you about physical design. The logical specifications of the system from logical design are transformed into technology specific details from which all programming and system construction can be accomplished. And the other one, implementation, which is the information system is coded, tested, installed, and supported in the organization. And last one, maintenance. An information system is systematically repaired and improved. And you see here's a table, products of SDLC phases. Here's the phase written here, and products, outputs, and or deliverables written in here. You can see and read this table. The heart of the systems development process. You see figures and written here. Current practice combines analysis, design, and implementation into a single iterative and parallel process of activities. Traditional waterfall SDLC. Look, here's a traditional waterfall SDLC in this figure. One phase begins when another completes, little backtracking and looping. Problems with waterfall approach. System requirements locked in after being determined. It means it can't change. Okay? Limited user involvement, only in requirement phase. Okay. Too much focus on milestones, deadlines of SDLC phases to the detriment of sound development practices. It means too much focus is harmful. Different approaches to improving development. Prototyping, computer-aided software engineering tools, joint application design. Rapid application development, agile methodologies, extreme programming. Now let's start with prototyping. Iterative development process. Requirements quickly converted to a working system. System is continually revised. Close collaboration between users and analysts. Here is a figure with prototyping. Okay, you see. Now, computer-aided software engineering tools. Diagramming tools enable graphical representation. Computer displays and report generators help prototype how systems look and feel. Analysis tools automatically check for consistency in diagrams, forms, and reports. Central repository for integrated storage of diagrams, reports, and project management specifications. The documentation generators standardize technical and user documentation. Code generators enable automatic generation of programs and database code directly from design documents, diagrams, forms, and reports. Look, here is a figure, a class diagram from IBM's relational rows. Okay. Case tools are really important. Look, here is a table, examples of case usage within the SDLC. Okay. You can look more carefully after watching whole chapter. Now, joint application design, structured process involving users, analysts, and managers. Several day intensive work group sessions. Purpose to specify or review system requirements. Look, its purpose is to specify or review system requirements. Now, rapid application development. Methodology to radically decrease design and implementation time. Involves extensive user involvement, prototyping, JAT sessions, integrated case tools, and code generators. Now here is a figure for rapid application development. Look, requirements planning and then user design. You can see it's RAD, which means rapid application development life cycle. Agile methodologies, motivated by recognition of software development as fluid, unpredictable, and dynamic. 3 key principles. First one, adaptive rather than predictive. Second one, emphasize people rather than roles. And third one, self-adaptive processes. Now it's a table, the Agile Manifesto. You can look more detailedly after completing all chapter. Now, extreme programming, short incremental development cycles, automated tests, 2-person programming teams. Coding and testing operate together. Now look at its advantage, extreme programming advantage. Communication between developers, high level of productivity, high quality code. Object-oriented analysis and design. Based on objects rather than data or processes. It's really necessary because almost every program needs to use object-oriented design. Okay. Object, a structure encapsulating attributes and behaviors of a real-world entity. Object class, a logical grouping of objects sharing the same attributes and behaviors. Inheritance, hierarchical arrangement of classes enables subclasses to inherit properties of superclasses. Rational unfinite processes, an object-oriented system development methodology. RUP, which means rational unfinite process, establishes 4 phases of development: inception, elaboration, construction, and transition. Each phase is organized into a number of separate iterations. Look, here's a figure, phases of OOSAD based development. Our approach to systems development. The system development life cycle is an organizing and guiding principle in this book. We may construct artificial boundaries or artificially separate activities and processes for learning purposes. Our intent is to help you understand all the pieces and how to assemble them. In summary, in this chapter, it means we, you learned how to define information systems, analysis and design, describe the different types of information systems, describe the information systems development life cycle, which means SDLC, explain rapid application development, prototyping, joint application development, and computer-aided software engineering, describe agile methodologies and extreme programming, explain object-oriented analysis and design and the rational unfinite process. Now, you see it's not difficult. If you listen carefully, you can easily understand, I think. Now we completed our first chapter. I hope you understood and learned lots of things. If you have questions, you can send us email. I will try to back to you. Thanks again for watching me and listening to me. I hope we will see each other on the next tutorial. See you later.